In example 5, we want to use the given information and the diagram to answer the question. So let's do the one on the left-hand side, and we'll read the given information, and then we'll try to find the missing angle measures. These line segment indications here, these symbols should really be over the PO and then the OM. They got shifted a little bit here. But let's take a look, and we're given here that triangle POM is a right isosceles. And that PO is congruent to OM. It's really important that you actually make those marks on the diagram itself. It helps organize your thinking, and you'll make less mistakes if you can do that. So PO and OM would be congruent. So we'll put tick marks there. Okay. Of course, meaning that these two angles were congruent. So if you need to, you can make those angles congruent. We'll put one tick mark there and one tick mark there. Remember, that's the angle side theorem, so if you have two congruent sides, the angles opposite of them are congruent. And we want to find the missing angle measures. You might be able to guess right now what these are. We want 90 plus this angle plus the same measure angle to add up to 180. There's really only one thing that each one of those can be. If you're having a little bit of trouble, you can label or make a variable up, and you can say, hey, let's make each one of these x. They have to be the same. And if you added up x plus 90, set that equal to 180, using the fact that the three angles on the inside of a triangle will sum to 180, you would combine like terms, get 2x plus 90 equals 180. You would subtract 90 from each side. 2x is equal to 90. My goodness, divide by 2. So x would be 45, making these angles 45 degrees. That's the Goldilocks figure for a right isosceles. It's a 45, 45, 90. You're going to hear it said like that quite a bit. So if we wanted to find the missing angle measures, the angle measure, we want to put our degree symbol right there. And you can circle that up. If it's bigger than 45, like 50, if each one of those is 50, it'd be 190 for the triangle, and that wouldn't work. And if it's any smaller, like 40, then you wouldn't make it all the way to 180. So there's just this perfect angle measure that works. In the right-hand side, given RAT is equilateral, so all three sides are congruent, we want to solve for, this should just be TA, and that symbol should be over the top of TA there. So let's take a look at this triangle. Let's make some tick marks here. You can make one each, or if you put two on each one, that's fine, as long as the number of tick marks is the same, and meaning that all three sides are congruent. We know that from the given information. Now what we can do is we can relate these expressions, this is an expression for the side length, this one too, and we know that these two sides, AR and RT, are congruent, meaning their measures are equal. And so what we want to do is we want to take the measure of one side, which is 4x minus 7, set it equal to the measure of the other side, which is 2x plus 3. Lots of different moves here that you can make. I'm going to subtract 2x from each side. 2x minus 7 is equal to 3, and we'll add 7. 2x is equal to 10, we'll divide by 2, and we'll get x to be 5. Now, if we made a mistake here, we'd like to be able to catch it. So what you can do is you can plug 5 in, or substitute 5 in for x, and see what happens. So we've got 4 times 5 minus 7, which is 20 minus 7, or 13. So that's the side length when x is 5. This one is 2x plus 3, so that's 2 times 5, which is 10 plus 3, which is 13 also. Now, this question actually doesn't ask us to solve for the variable here. It does ask us to solve for TA. Well, TA is congruent to, here's TA down here by the way, it's congruent to all three, or the other two sides. And so we know that the measure of TA is equal to 13. It's the same as each one of those. So this is what you want to list here. And when we state that the measure of TA is 13, we don't put the little line segment over the top there.